Hello and welcome to Code FA Academy. And we are now in the module 3 of our generative AI course. And this model is all about image and media generation. At the end of this lesson, you should be able to explain how AI creates images from text prompts, identify common AI image generation tools and models, identify the basics of text to image prompting, generate and improve AI images using different prompts, and recognize how style, lighting, and composition affect AI generated images. So now let's head straight into it. When we talk about AI image generation, this is one of the most powerful and creative uses of generative AI. First, many people thought of AI as something that only writes text, but modern AI systems can now create visual content from simple written instructions. So, what is a text to image generation? Text to image generation means that AI takes written language and converts it into a visual image. Simple terms. The user will write a prompt, AI reads and interprets the prompt, and the AI will create an image based on what the prompt describes. So, based on this, AI cannot generate illustrations, posters, portraits, concept art, product visuals, educational graphics, and social media images. Now let's look at how AI creates images. So the generation works through models trained on millions of images and descriptions. So during the training, the model learns relationships between words, objects, colors, shapes, styles, scenes, textures, and visual arrangement. So instead of memorizing one exact image, AI learns patterns from many examples. Get it? So what you need to know is that when the user enters a simple prompt, an example is a futuristic city at sunset. We demonstrate this very soon. The AI will analyze the words that is futuristic, city, and sunset. It will then combine visual patterns associated with these concepts and generate a new image based on probability and learned patterns. So, some important points to know is that AI does not copy one single image. It generates a new image using learned visual patterns. The output depends heavily on the quality of the prompt, and better prompts often produce better results. So, let's look at what happens in the background. So, these can be divided into three important stages. That is the model training, understanding of the prompts, and generating the image. So, the first thing is training the model. So, before an AI tool can generate an image, it must be first trained on a very large collection of images and text descriptions. So during training, the model is shown many examples such as the image of a dog with a labeled dog, picture of a beach, labeled beach, and so on. So over time, the AI will learn the relationships between words and objects, words and colors, words and artistic styles, words and scene arrangements. So for example, it can learn that sunset often involves warm orange and pink lighting. Futuristic often includes glowing lights, modern structures, and sci-fi elements. So the training stage is where the AI builds its understanding of what things would usually look like. And the second stage is understanding the prompt. So once the model has been trained, the next step is understanding the prompt that is entered by the user. So for example, we have this prompt: a futuristic robot standing in the modern classroom, 3D illustration, bright lighting. So when you feed this prompt into your AI, the AI will try to break the prompt into meaningful instructions. So it may interpret the prompt as the main subject being the robots, the setting, which is the classroom, the style, 3D illustration, the theme, which is futuristic, and the lighting, which is bright. So each word or phrase gives the AI a clue about what should appear in the final image. And this stage is very important because the AI needs to understand not what objects should appear, but how the images should. And the last thing to look at is generating the image. So after getting the prompt, how does the AI generate the image? So AI uses special image generation systems called models. And these models are the engine between the image generation or image creation process. So different AI tools may use different image generation methods, but we'll be looking at two in this lesson. So the first one is diffusion models, and the second one is GANs, that is generative adversarial networks. There are other ones too. You can also read about VAs, that is variational autoencoders. That's also an image generation model. So we'll be talking about diffusion models and GANs in this lesson. So a diffusion model is one of the most common and powerful methods used in AI image generation. So how does it work? It works by starting with random noise and gradually turning that noise into a clear image. An example of an AI model that uses this is Copilot. We would see that when you are generating an image. So it will start with the noise, then it will turn that noise into a very clear image. So let me break it into simple terms. So imagine a screen filled with random dots, blur or static. So when it's first generating the image, it will first look like noise, that is meaningless noise, random objects or no clear objects. Then step by step, the AI will remove the noise and reshape it into something that matches the prompt. So why do we call this diffusion? So during the training, the model learns how a clean image can be turned into noise, and then how to reverse that process from clean to noise, then from noise to clean. So when generating an image, it moves from noise, rough shapes, clearer details, then final image. You get it. So diffusion models are very effective at generating highly detailed and realistic images. Why are they very important? They are very popular because they are very good at following prompts accurately, generating detailed visuals, producing realistic lighting textures, and handling different artistic styles. So most AI image tools rely on this method. And the next one to look at is the generative adversarial networks, which is known as GAN. GEN. So although the name sounds technical, the concept is really simple. So let's say in simple terms, let's say the police and the thief. So GAN has two main parts, that's the generator and the discriminator. So in this case, the generator would be the thief, the discriminator would be the police. So the generator would generate a fake image, and the discriminator, which is the police, will check whether the image looks real or fake. So the process is like this. When the generator generates the image, the discriminator judges the image. If the image looks unrealistic, the generator improves. The process would be repeated, so it will just be going back and forth. So over time, the generator becomes better at producing realistic images where the discriminator can't tell whether it's real or fake. You get it? So you can think of it like this. A student is trying to draw a realistic face, another student is acting as a strict adject. The judge points out what looks wrong, then the artist will keep improving it over time. You get it? So GANs are very popular because they are very good at generating realistic human faces, artistic transformations, fashion visuals, and style-based prompts. You get it? So, however, many newer systems prefer diffusion models before because they often give more stable and prompt accurate results. So here are some differences between diffusion models and GANs. So diffusion models will start with a random noise. GAN uses two competing networks. Diffusion models build images gradually, and GANs improve through competition. Diffusion models are common in modern image tools. GANs are common in earlier image generation systems. Strong at prompt following for diffusion models, strong at realistic image generation for GANs. Then diffusion models are often more stable, and GANs are sometimes harder to train. So now let's head to some of our AI systems and look at or try our hands on some simple prompts and see what we can do. Right. So let's generate some simple images with some of these AI models. So the cat wearing sunglasses on the beach. Select create an image so that it knows what we want to do. So whilst we wait, wow, fix the integration with ChatGPT. Let me go to Gemini. So same prompt. Let me copy the prompt and you try it. Right. So using Gemini and Copilot for this since the ChatGPT is trying to do something here. So as we talked about the diffusion models, you can see that it started with a noise and it is now making the picture clear for us. You can see this is the image that we have from Copilot. Let's go to ChatGPT. It's not done it. Let's head to Gemini. Create image. Let's describe. So a dog chasing a cat in a typical African setting. So let's use Gemini for this one too. Let's see if ChatGPT is done. Still one of them. I think because we've hit our limits, we might not get the image. So whilst we wait for Gemini, let's switch it up here. So 3D illustration of, let me select generate image so let's create an image of a 3D illustration of African children playing football on the beach. So let's see what we get for this one. So you can see this for the prompt that we give to Gemini. Let me I see this what here. So you can see the dog chasing the cat, and this looks very real. Get it. So let's say to Copilot and see if think it's done. It's coming. So we have this also over here. See, you wanted a 3D illustration, so that's giving us. But these are just some simple ways to generate images using some of these models. Now, so this brings us to the end of the first part of this lesson, which is introduction to image generation. And see you in the next part.